morning. Good morning, all. And thanks for joining me for this session. And also, warm welcome to those who join online. My name is Sheen Brisals. I'm from the Lego Group. And this conference is special because this is the first in-person conference I'm talking since the lockdown. And the last conference I spoke in person, that was also a serverless conference, serverless days. So that's super exciting. This is not a deep technical talk. This is more of an experience report, bringing up with the best practices and some of the recommendations for those who journey with serverless, those who make a start with serverless, how they keep going. So I'm also a AWS Serverless Hero. So this is a program AWS recognizes those who are active in the serverless community. And you can find me on Twitter, LinkedIn, or I also do blogs. We have a new serverless hero there, Philip Wave. So please interact because Philip and his team, they have a bunch of engineers working on serverless, so there's plenty of knowledge there as well. OK, so today's agenda, I'll briefly start with what we are doing with serverless at the Lego Group. And I think that's important for me to clarify, because as a big organization, there's always this misinterpretation that everything is serverless. That's not the case. And then we will briefly look at what is serverless. I'm not going to go detailed, because you must have heard many times over this conference or over the years. And then we'll see how do you make a start with serverless. And then once you made a start, how do you keep it running and keep it they're continuing with serverless. And we will close up with a few bits on how to keep everything going when you are into serverless. OK, so serverless at the Lego Group. So I work for a department called Marketing Channels Technology. That is basically around the Lego.com experience, the e-commerce, and everything that happens behind the scenes. So when I say serverless, not every department or team across the Lego Group are into serverless. There are a bunch of other technologies, from on-prem to Azure to AWS to Kubernetes to Scala, Java, all sorts of things are there. OK, so keep that in mind when I say serverless at the Lego Group. So as I mentioned, this is Lego.com. And people often ask, what do you do in serverless? Which part of the operation is serverless? So if you go to Lego.com to buy things, you put things onto the basket, you go through the checkout flow, you make a payment, you complete the order. Behind the scenes, everything that handles the logic and interacts with the third parties and everything, all handled by serverless microservices. So that means serverless is being used to front customer-facing applications, not just the any old batch job or the background processing things. So that's what we do. And if I go back a few years, so spring 2018, we had no serverless. We were kind of thinking of moving to a new platform. And then a little over a year, 2019, July, we moved entire Lego.com onto serverless. So this happened. So it was a kind of a really fast-paced development, moving everything. It's not a lift and shift. We rewrote everything with serverless and then launched the site onto serverless. So in terms of the team growth, so early days, no serverless, a few engineers doing front end and the back end. And by 2019, we had two teams, the typical front end, back end split, and fee services and Lambda functions and things like that. And last year, it grew. So last year, we had more squad, more engineers, and more services. And today, it grew even further. So we have over 100 engineers spread across different squads. And I lost count of services because as more squads come up, they operate with their own AWS account. So they kind of own their own products and things. So it's difficult to go around and look for it. So that's sort of the way we operate. When I say squad, it's basically 8 to 10 people, engineering lead, product manager, senior, junior, mid-level engineers, plus QA engineers, everyone working together, owning that product, and bringing the solution to the customer. So that's what. Okay, so these are of the spikes since we launched, becomes kind of a normal occurrence. Every month when there is a new product launch, we see spikes. With serverless, there is not much for us to do. I mean, of course, the front end and the GraphQL layer we have, they run on Fargate. So engineers do some bit of scaling and allocating, a bit of things there. But when it comes to serverless, it's mostly nothing. If at all we do anything, it's basically adding extra provision concurrency for few critical Lambda functions. That's all. So let's move on to serverless. What is serverless? So probably you all know, the serverless. But if you briefly look at the evolution of how we got there. So initially we had the on-prem systems, and then came the infrastructure as a service, and came the platform as a service. That gave us so much of flexibility. Things like Elastic Beanstalk and things like that made things simple and easy for us. And then the function as a service came hold, and that's when kind of serverless picked up. And we are all here for the same reason. So the definition of serverless varies. So basically, it's a cloud computing model, and obviously no servers to manage for us. There are servers behind the scenes, and the pay for compute and the scalable, highly available, all these things, the standard things, scale to zero, low cost, all we know. But for me, the important thing is why we use serverless. The misconception is that often people think that serverless is a Lambda function. No, it is an ecosystem of many things. Lambda functions is part of it, but there is more than Lambda functions when we say serverless. There are plenty of managed services where we don't need to do anything. They come together to provide us the serverless service or application that we build. And then the beauty is that the granular level tuning or optimization opportunity we have with serverless, I never seen with any other technology. Even within a microservice, when you have two Lambda functions, you can tune them separately. If you have two different, say, NoSQL DynamoDB tables, you can provision them separately. So that is kind of the level of granular optimization security setup we get with serverless. And the other thing is, it's a perfect technology when it comes to the agile, iterative, incremental approach, because it's so easy to come up with something, iterate, make it better, evolve. And the other thing, this is really important if you are in a serverless team, it brings the engineering diversity. What I mean is, like, say you are doing your Lambda functions in Node.js. They are not just programmers nowadays, because they need to understand security. They need to understand how to create or set up a S3 bucket or a table, how to secure them, how to encrypt, how to even take their, they set up their pipelines and DevOps and all sorts of things, how to look after their services. So that's an important aspect from, the legacy of the olden days to how they do, serverless these days. So that's why I say it brings the, sort of the completeness to engineers. So how do we start with serverless? Always there is a first step, right, before everything happens. So if you are new to serverless, keep in mind that no one starts perfectly. Always make mistakes. But the important part is we make mistakes, but every iteration we try and get better. So that's the important bit, and that's what gives us the freedom to scale fast. So if I go back, so this was the setup we had in 2018. The big rectangle is the on-prem legacy platform. So there was a need for us to try out serverless, and that's when we set up the first serverless microservice. It was a simple service, one API gateway endpoint, and Lambda function, talking to a SaaS platform. So this is where it started. So this was customer-facing, and since then, the business, the stakeholders saw the benefit. They saw the scaling when this was put up for a Black Friday high-traffic season, and that's when the confidence came, and the whole story began. At the same time, there were services behind the scenes like data pipelines. Those were also, in development as well. Okay, so I often talk about, this is really important, because every day when I talk to engineers who are new to serverless, I face the challenge. You need to have that mindset shift to think differently when we come to doing serverless, because the asynchronous nature of things, the event-driven aspect, the ephemeral, stateless, these things not easy for someone coming new to serverless to understand. Those who are with serverless, we know that, okay, yeah. But those, people who are new, this is difficult. So that's why it's important to kind of bring up that mind shift change in the engineers. And also think of the microservices as smaller, granular level service, not necessarily the typical monolithic style of microservice where you think of your entire domain as a microservice or a subdomain as a microservice. When it comes to serverless thinking, there are a number of things you need to kind of, keep thinking or keep feeding to the teams. So obviously the domain-driven design concepts should be there. The API contracts, the schema, and the automation, and all these kind of different aspects needs to be brought in to the team when we start with serverless. So if you think of the adoption of serverless, I always kind of find these two different categories: speedy adoption as well as the experimentation. What I mean by speedy adoption is teams who look at serverless, they want to go something of serverless, they start something simple, they experiment, they iterate, they evolve, they bring up the solution, then they try to do the perfection and everything, and do the continuous improvement on top. Whereas the endless experimentation, there are teams who are what I call the purists or perfectionists. They try to bring up their documentation, together before even start writing a Lambda function. So they spend 4 months doing the documentation, but end of 4 months, the technology moved on. So they need to start writing again. The other important thing, it's the vendor lock-in debate. It's an endless debate, goes on and on and on. There are so many, views and opinions and debates and arguments all there. The problem is these teams or companies, they get locked in with the vendor lock-in idea. They never get out of it. So what happens is the early adopters, they race ahead. They bring more services, more things to the customers, whereas the other ones kind of grumble and difficult to get going and struggle. So these are some of the things to keep in mind. Again, reiterating the point that start something simple and get going. So how do we now operate with serverless? So Dave Anderson, he was part of Liberty Mutual and introduced the serverless first concept there. So he mentioned this to think of the event-driven nature, because that gives us the speed of innovation or development and iterating it to get to perfection. So one of the things you keep in mind is that there are many things. It's not simple. Okay, though I may sound serverless very simple, it's not simple. There are many things to look at. What frameworks you use? You get bunch of things all of a sudden. Oh, serverless framework, or CDK, or CloudFormation, or Terraform, or this or that. And then you look at programming language. Which one do I use? Security, CI/CD. All these things are there. But if you are new and starting, if you have growth expected, then have some sort of a guardrail so that everyone can be uniform across, at least during the initial stages. Say, for example, your team or your organization have a particular skill. Say they have JavaScript or something like that. So if you're going to serverless, try to use Node.js, because you don't need to kind of retrain them. Don't try to bring a completely different language, so that kind of will cost you and the effort, and then kind of slows your momentum. So these are the things, and the framework. Choose something and just go with it. And in future, if you want to change something, you can always bring in a different one. Code repository. Decide monorepo or multi-repo or things like that, whichever works for you. Solution design is a good thing. I will touch upon later. It's an important principle that it helps engineers to bring out the thinking before they start building something. And the API guidelines is important because contracts, schema are core when we think of serverless and microservices. So having those API guidelines, how do we protect the APIs, what mechanism we use, those are the core concepts that we need to keep in mind. And I already talked many times, the iterative incremental approach. So I often use this analogy because, as I mentioned in the previous slide, there are many things at stake when you start serverless. The beauty is that it's once you kind of taken off with all the heavy lifting and all the thing in place, then it's basically kind of free falling. It keeps going because you have everything in place. All you need is just add more engineers and keep more build more services and keep it going. Another thing is often teams engage in lengthy reviews and discussions and debates and everything. Just do it, simple. I'm not saying you shouldn't discuss or debate. Do it, but try to get to a conclusion, agree something on, and keep going. So that sort of gives you the MVP mindset. Get something minimum valuable to the customers or to the the stakeholders, and then build from there. And Setpiece microservice. This is something I came up with the term. So what I mean is, if you're building, say, a customer or a payment service, so you need to have the visualization of that whole thing. But when you start the work, identify the parts within it that you can start working on. So that's my kind of the thing. So I like this dialogue from the Mamma Mia movie. So there's a conversation between a man and a woman. And the man says that, I don't think it's that simple. Nothing is simple. I think they talk about some life issues or something. But the woman will reply back, everything is simple when you break it down. That's exactly, I'm talking here. So you need to make, a kind of a starting point where you can, go from there. So when I say set pieces, so this is a scene from a movie. So if you think of filmmaking, they shot in kind of, sequences, set pieces, right? And they bring everything together later. And same thing with the theater. You go to, watch a play or something. Again, there are sequences of, a scene. So they change the set or pull the curtain and some kind of, background music or voiceover will keep things going together. So in football as well, this is where I, they borrowed the term set piece. There in English football, there is something called set piece play, where they don't kind of, run 45 minutes from end to end nonstop. What they do is they create opportunities. So they score goals as set piece plays, say like a corner or a free kick or something like that. So they expect that. So what happens is during their training, they specifically practice that. So that's kind of the concept that if you think of smaller pieces, building services, you can build them, you can experiment, you can test them before you kind of launch that into production to link with other customers. Same with, if you're building a big Lego model, you build, smaller pieces of models and then kind of bring them together. So that's sort of the set piece, sort of mindset. So give you an example. So this is a typical, front end, back end. So in the back end, you have a bunch of microservices. So they all kind of represent customers, payments, or products, etc., kind of a domain specific or subdomain specific. So if you take one particular payment, so that's your vision, that's your building. So in the set piece view, you will basically break it down to number of smaller services that can be part of and within the same payments domain. So you have the authorization part or the settlement or refunds and all these things. So these things can be thought of in serverless world at smaller microservices. And how do you then bring them, how do you bring them to life? So you have an independent deployment pipeline stream for each of these services. It is possible with the tools like, I know in JavaScript they use learner or write selector script to know exactly which service modified and deploy that one. So the beauty is that you're not deploying the entire payments domain all the time, when something changes. You are deploying just the smaller service that changed. So how do we kind of bring these together? So mainly three things. So API is there. So API is mostly in a synchronous invocation situation, and it has a contract. And messages is often the async, push-pull pattern, and decoupling. And it also often gives you the buffer to kind of soak in the volume of traffic before acting on it. The other one is the events, the typical event-driven, asynchronous, publish, subscribe nature of things. So these are the things that we can use when we have these sort of Setpiece services and to come to bring them to action. So automate everything. So this, I don't need to say, I think if you into any of the, not necessarily in serverless microservice building, you know that the account separation is something I will touch upon. It's an important aspect because I think it's changing nowadays, because in the early days, I know that people use one cloud account, whether it's AWS or Azure or whatever, and they will then try to, kind of add with some kind of developer or some stage variation, and even production they run in the same account. Don't do that. Keep separate account, because it doesn't, it won't make any sense. If you think of a service, so we have different cloud environment, and this environment, basically, logically, we have this sort of separation, right? Otherwise, they are the same. So if you have a function in your develop, it has the same potential as the in production. I mean, these days it's rare that people change the memory setting or other things across these environments. Like in the past, we used to have dev environment, the queue and the prod. So dev is always the worst, queue is slightly better, prod is the top notch. But these days it's all gone. I mean, there are certain services where you would kind of do the separation, but otherwise mostly the same. The other beauty of cloud, the account separation, like for example, if the payment service wanted to add a sandbox environment, it becomes easier for that service and that team to bring up a new account and set that as a pre-prod or sandbox environment. So that's the cloud account separation to keep in mind. So the solution design I touched upon earlier. I'm not going to go through the details set. I did a couple of blog posts on it. So the purpose of doing solution design is making engineers think before they build anything. So thinking will bring how can the service be agile and how can they be modular and all sorts of things. They will think before they start adding something. Otherwise, if they start programming something, they will think, I missed something, I need to now change, etc., etc. So that's the reason why I recommend doing solution design. The other important aspect is doing a threat modeling, if at all possible. And again, it's the process that matters, because when engineers sit together to think about, I don't know, if you follow Stride or any other threat modeling principles, they get the opportunity to talk about it. Okay, so if you have an API, ask the question, how do you protect? How do you protect someone kind of maliciously, flooding with the millions of requests? So that sort of the thinking is very important as part of this process. That's what I usually get out of this modeling when I ask engineers, okay, now let's do the threat modeling. So then obviously you kind of look at the other aspects and document things, etc. So again, I have a couple of blog posts if you are new to threat modeling, and I follow the Stride principle and I go through detail. WellArchitected. So this is from AWS. So they have the WellArchitected framework. Now they have the 6 pillars, including the sustainability. So they talk a lot about the best practices and how to kind of build something for reliability, something for cost efficiency. So this is an important thing. And for serverless world, there is a serverless lens. So this is something useful for the teams to put in place. So what we do is we have something called a service audit in place. So we incorporate serverless framework and also a bunch of other best practices in place and make sure every microservice, before it goes to production, they need to go through the checklist. The thing is, like I mentioned earlier, early days, we had to sit with engineers and make them understand, okay, is this there or not? If it's not there, okay, raise a Jira ticket to fix it, etc. But once they got used to it, they do it themselves. Nowadays, it becomes a tick box because most of the best practices like structured logging or API protection, all part of the the framework or the best practice they do. You don't need to kind of tell them that you need to have alerts and alarms are all part of the service they build. So that's the beauty of initially you do some bit of heavy work, then becomes easier later on. Now, let's see, how do we keep up with serverless? So serverless, as I've been saying, kind of requires a new way of thinking from the old way of doing things and running applications. Now, serverless evolution, this is AWS specific though, so happened only in the last few years. Okay, API Gateway came in, the popularity, Event Bridge now is taking storm, and it's a long future ahead. So I had a chat with Jeff Barr from AWS. He said, Sheen serverless is just starting up. It's a decades of future ahead. So that's the reason why there are so many things changing in serverless and so many new things coming up all the time. And that's the reason it is a challenge for teams to keep up with all the things that happen. It's not a settled ecosystem or technology at all. So we'll briefly look at a few things. So one way is to encourage learning. Engineering teams, they need to up on it. They need to know exactly what's going on. They need to be on top. And the second thing is refactoring. Because there's so much change happening, there's so many new features coming out every other day, you need to have the mindset of refactoring to make things perfect or better. So the other thing is serverless teams. Growing serverless team, growing your own kind of knowledge pool within the organization, within the team is really important. That's what kind of brings up all these new things to others' attention and makes them to do things. And finally, be sustainable. Think of the sustainability aspects of things. So when I say continuous learning, there are a number of ways, conferences like this and many other conferences around the world, podcasts, newsletters, and so many things happen, meetups and things like that. So these are all opportunities for everyone to grasp the new ideas and new ways of doing things, architectures and patterns, all sorts of things. So yeah, so things I mentioned, so they are good resources. And continuous refactoring. Refactoring is not new. It's been there for ages. So those who've been through the 90s probably know that very well. So the difference is that back in those days, the refactoring was mostly on OO principles or the language. So it's one of my favorite books back in those days with Martin Fowler. He said it's a process of changing software system. But like I mentioned, those days were mainly to do with the language or the OO principles and things. But when it comes to serverless, it's not just about rewriting the code. It's rearranging or rewiring. So many things can also be part of the serverless refactoring. So that, again, is the kind of the mindset that we need to build in the team. And the granularity I mentioned earlier, so that's another important thing. It's not just kind of, one done. It can be difficult. So I will talk about how to, get this to an organization. Serverless refactoring is, infrastructure refactoring, performance tuning, and refactoring for cost. There are so many things can happen. Because if your cloud provider, released a new service, suddenly you need to now look at, okay, where does it fit? How, what does it make it better from what you already have? So these sort of the aspects you need to kind of, keep in mind. Now, this is an important point because when you say refactor your stakeholders, they think, oh, I thought, you're doing new technology, you're doing serverless, because they are in the previous generation mindset that refactoring only happens once in your lifetime, then you kind of, move everything from C++ to something else, Java to this and that. No, you need to make that clear, and you need to make them understand in their, language. And the other thing is keep it part of your development process, how to engage teams. And another thing is, when it comes to refactoring, often the traditional teams think, oh, refactoring, not again. Because that's kind of the way, because complex code and all the spaghetti code base and all sorts of things that we hear, that's the mentality they have. But now we have a different technology to play with. So that's why it's important to create that motivation. So simple things, when you talk to business, so say, for example, if you did refactor, API, then, you attain latency, they may not understand what you're talking about. So you need to talk about in terms of, oh, it's going to improve your NPS score, the Net Promoter Score for customers when they visit your site, and, to kind of translate to their, language. So if you're increasing your throughput, processing more messages, you need to say that, oh, now we are in a position to serve more customers. So that's what the message they like to hear and they understand. So that's the thing. And justification, so development process. So I do a talk on how to go serverless team. So in there, I have a step called a renewal or retrospective phase. This is where I stress upon taking a bunch of these things as part of the development ecosystem or environment. So the new technology uptake, the refactoring, can become part of this particular phase. This can be hard in certain teams, but try to set a sprint or two every quarter. Bargain it with the product owners or stakeholders to improve things. Not necessarily serverless, could be other things in your team as well as part of the work. So engage or encourage the engineers to kind of note down something you want to improve the next iteration or next phase. So that way things get listed and nobody will forget things. So, and the business buy-in I mentioned for the same reason. Right. And, the other one is that when you did refactoring, for example, when you see the benefits, don't just sit quiet. Talk about it. Bring it to the stakeholders and show them, hey, look here, we did this thing. Now this is kind of clocking, a few milliseconds lower, or adding, supporting more customers and things like that. That's important to get that, the products and the engineering teams kind of, in good rhythm. And technology motivator, this is aiming at engineers. So when a new service comes up, encourage them, because new patterns come up or new services come up, engineers always like to work on the new things, right? Because they don't like mess around with the complex code base and do all sorts of things, but they like new things. So it can play new patterns, and so this is about event bridge and step functions. They introduce the task token to decouple and synchronize, asynchronous flow. These sort of things will excite most of the engineers. So you can make it as a motivational factor to bring them to do this refactoring. Because if you go back to the years, that typically used to have the maintenance teams in so organization, probably that's the most demotivated team you can find in the organization, because there's no life, because it goes through a phase of maintenance, then that's it. They do the bug fixing and all sorts of things. But things changed now. I'll briefly touch upon what changed. Anyway, so back to the motivation. So kind of the good things that we all know for the teams. Creating the knowledge pool, I think I touched upon the, how to kind of bring in the, know the things that are happening in serverless or the community and the technology. Similar thing. So internally, you can set up specific channels. You can encourage certification. So have those kind of conversation, engaging all the time with engineers, because otherwise they will lose track. The thing is, not everyone active on social media engineers. Only probably 10 or 20%. The rest never look at it. So don't assume that because there's so much happening on Twitter, everyone knows. No, they don't. So that's why important that you need to kind of bring that to the engineers. So a couple of important things on this one. One is giving engineers the freedom to come up with the design. It's not common in all teams. So not just architects. So if you are a engineering lead or someone in a team, give a particular design to an engineer and say, okay, why don't you come back with a design or architecture for this one? Then discuss with them, identify the problems to improve or areas to improve. That's the way you grow engineers and give them more kind of technology responsibility as well. And of course the DevOps practice, push them towards owning the pipeline, deploying to production. Anyone can deploy to production. You don't need to kind of have dedicated people touching the prod environment. So that sort of the processes will encourage engineers. And finally, sustainability. Sustainability, often when we talk, we say that, okay, it's to do with the sustainable environment, the nature and the green things and all sorts of things. But sustainability itself has a kind of vast meaning. So it can be anything. So basically to keep something going. So if say that if serverless architecture conference is happening for many years, over the years, that means they are able to sustain it, right? So they're doing something good to keep it going. So that way, so I have this, I came up with this sustainability triangle. So on one side we have the serverless products in place, the products we develop, and then we have the processes that can help the sustainable, build sustainable products and also operate on cloud, thinking of sustainability of the environment. So I call this as a sustainability triangle. So what I mean is when I say product is building sustainable solutions like we need to kind of, as we start with something simple, we need to keep that application going. It's not like we build something and that's it. No. In serverless, as we saw, we need to sustain it going from MVP to the most valuable or beyond. So that's a journey. So that's, again, how do you sustain? And then processes like the process that help to make these things happen. And of course, when it comes to cloud, we are more looking at the environment and beyond, and how do we apply the best practices. And especially in AWS, I think all cloud providers have their own kind of sustainability thinking. So AWS again have this sort of shared responsibility when it comes to sustainability. They say that, okay, we look after the sustainability of the cloud, and you look after the sustainability in the cloud in your application and things that we deploy and operate with. So when I say, this is what I mentioned earlier, so we no longer do this, the maintenance and bug fixing. Rather, we do the sustainable things. So because we are always kind of an agile iterative, we are always growing. So we do the deployment, operate, and we sustain it to make it kind of grow and beyond. And how do you do that? How do we build sustainable solutions? Like a few of the things we already discussed, it needs to be a modular. We need to build modular applications, so because that will give us the extensibility. And also, when you have these sort of granular services, it improves the observability, all these good things that will come together. And when it comes to processes, the agile and iterative processes, apply the lean principles, don't do waste, don't do things unnecessarily. And if you build a prototype, think if you can kind of sustain it to as part of the MVP. Don't just throw it away and start all over again. Because it's easy to say that, but when you operate on the cloud, think of the resources it may use and all the the sustainability behind the scenes. So that's why the processes are important when it comes to sustainability. Cloud, this is from AWS. This is shows the shared sustainability model I mentioned in the cloud and off the cloud. So sustainability off the cloud is looked after by AWS, and in the cloud is our responsibility, how we build applications. So they take care of resource sharing. How do they optimize the compute usage and power? And when it comes to energy, renewable energy, and where do they host their AWS region or the data centers, and how do they get the energy or feed the cooling, all sorts of things. When it comes to our responsibility, we need to think of data store policies and how we kind of optimize our solutions, apply the best practice and things like that. Okay, so takeaway points. When we start serverless, be humble. Okay, don't go overboard. Just relax, start quietly, and then from there, climb up. And have the mindset change. That's very important because that's what gives you the agility to move up. Think of smaller set-piece microservice. Granularity is core of serverless. And refactoring, I talked about, this is something important. I don't think this is a bad practice in serverless modern technology. It is part of the development process. And grow experts in your team and think sustainability. So I just leave you with this thought. So if serverless can give you and your teams or organization as a slingshot to kind of a flywheel to, to bring customer solutions faster, and then we must, adopt and accept that it's a technology that we can, make use of and, achieve great potential. So thank you so much. That's all. Thank you. Any questions? I don't see any questions online yet. Yeah.
Where do you see the boundary of serverless? So where do you reach its limits? Where do you push it? So what are some scenarios where you cannot use it?
Okay, so the question is the boundaries or the limits of serverless. Where can you use, where can't you use? Okay. Now, it depends on your use case. Say, for example, you know that the serverless functions, they are, definitely they have a certain limit in terms of, minutes they can run and things like that. So if you have workloads that requires beyond that, then obviously. And again, then data volume, that's another thing. Even though the cloud providers are upping the resource limit and Lambda function, for example, has 10 GB memory, 10 GB local, there can be use cases where it's just not feasible. A, because you need more space. B, if you put all the 10 GB memory and things, it's going to cost a lot. Yeah. So that's where you need to have that trade-off and the open mind to see, okay, what's the best here? So there are situations where it's perfectly fine, like I showed, the traffic spikes and things, and the ability to come up with solutions faster. So this is a perfect thing. And as I mentioned many times, don't think that simply starting up with serverless is going to solve every problem. You need to put certain best practices and things in place in order to move up. Recently, a couple of days ago, there was someone shared something that they've been trying serverless for a few years and now gave up. All the reasons they listed, you can replace serverless with any other technology because they simply didn't follow, in many cases, these best practices and made a mess of things probably. So. Anyone new to serverless here today? Or thinking of moving to serverless? Okay, good. Okay, so if no more questions here, no more questions online, then yeah. Oh, yeah, go for it.
What is your usual design process when you are designing a new microservice approach?
Okay, so the question is, at the Lego group or in my teams, how do they design a microservice when they start thinking of microservice or thinking of developing something? So it comes from, say, obviously from stakeholders and the requirements and things like that will come through. And the process we often follow, I mean, it depends, certain teams may be different, but the engineers I work with is like, they take the requirements and they initially arrange a brainstorm session. So during the COVID, they use Miro board or one of the online tools to bring all the team engineers together, not just engineers, everyone basically, product owner, QA engineer together, to brainstorm the idea and get all the different things. So they take away all those points back, and that's what feeds them into doing their initial solution design version. Okay, and in between they may have conversations with myself or other engineering leads and product owners to clarify certain aspects. But that's kind of the feeding ground for them to start the solution design. So solution design will come up. They usually come up with a logical view of things, not the, they don't use the typical cloud icons and things like that. This logical view and the logical diagrams could be more than one. It's basically for the stakeholders, because they can take these diagrams and sit with the product owner and discuss, whereas they won't understand the AWS icons, for example. So they do that, and then obviously they come with the design using the architectural, the icons and stuff. The two other things they do is they look at the different event patterns or event schema. And the other thing is they detail the table design if they're using NoSQL, Dynamo, or something like that. So when they do the table design, they look at, okay, what are the access requirements there, the query patterns, for example. So that kind of leads them to identifying the partition keys or the indexes and things like that. So they kind of list down. And the other aspect is the event, because most of our things are event-driven. We have event bridge in the middle of every team. So identifying the events and classifying them, the important. So we follow a particular structure, which I think is kind of getting common across the event bridge, people who follow that. So that happens, and then depending on the size of the work, if it's a simple service, they incorporate any security threat modeling as part of solution design as well. If it's a bigger one, they then do a separate threat modeling exercise. So that, again, brings all the people together to brainstorm, go through we follow the STRIDE principle. So go through that and identify all the things and come with a separate document. If not, it's part of the solution design. So that will then get to review with everyone and then get some understanding. Even if there are a few areas that needs to be detailed later, that's not necessary right now, we make a start from there. So then they go through the ticketing phase, start creating stories and epics and all sorts of things. Yeah. Okay. Yeah. Thanks again. Thanks all. Enjoy.